the value is null, it will return the specified character or specified value. This is particularly important when you're trying to do arithmetic expressions with values from a table. Remember, we mentioned before that using arithmetic expression with a null value, we always return a null value. So if you know that a particular column could contain null values, you might want to use the NVL function. Now, the rules about NVL functions is that the data type must match. So if you're using number, then the two arguments that you pass to it must be number. In this case, commission percent will be number and 0 is a number. And the higher date is a date type, so the other argument will be date type. Let's see how the NVL function works. In this case, what we're trying to do is we're saying that in the commission percent column, if there is a null value, this particular expression should return 0. But if it's not a null value, then the commission percent will be returned. In this case, there happens to be no. All the columns here happen to have null values, so 0 is returned for all of them. Now, the second expression is the one that will probably bring out what I have been talking about. In which case, we're actually trying to calculate the salary for every employee. However, remember that some employees are on commission and some are not. So we're saying that if the employee has a commission, then we should multiply it by 12 and multiply that by salary to add it to the salary multiplied by 12. Now, the problem could arise if we did not use the NVL in this case. Now, assume that we're looking at a particular row where the commission percent is null. This whole expression will result in a null value, and then this also will return into a null value. So it is very important that we use NVL in this kind of situation, so that if that commission percent is not specified, a value of 0 will be returned, and that can be easily dealt with in arithmetics. The NVL2 function is an extension of NVL function. And how it works is that if the column specified does not have a value, if it has a value, then it returns the second argument. If it does not have a value, if this does not have a value, then it returns the third argument. In other words, if the commission percent is specified, then the expression salary plus commission will be returned. But if the commission percent is null, then it will return salary. And that's what you see here. For this first three rows, there is a commission percent specified, and that expression will return salary plus commission. However, for the remaining ones, there's no commission percent specified. That is why SAL is returned for all of them. The way the null-if function acts is it basically looks at the two expressions, the two arguments provided. If they are equal, then it returns null. If they are not equal, it returns the very first of the arguments. So let's take a look at this. The first argument to this null-if function is a nested function length, which is the same thing as what we have here, given as expression 1. Then we have expression 2, which is the length of last name. Now, these are the two arguments that is passed to null-if. So, which means that if this expression 1 is the same as expression 2, then the result would have been null. But if they're not, then the result will be expression 1. And that's what we have here. Expression 1 is not the same as expression 2, so it returns expression 1. But in this case, expression 1 is the same as expression 2, so it does not. It returns a null value for that particular row. The qualis function is yet another extension of the NVL function. And the advantage it has is that you can take multiple alternate values. So if the first expression is null, it returns the second expression. Otherwise, if that is null, then it takes the third. If the third is null, it takes the fourth. Let's take a look at how that works. In this case, what the qualis function will do is if the commission percent is null, then it will return the salary. If the salary and the commission percent are both null, then it will return 10. SQL provides us the ability to do if then else logic without having to write a procedure. And the two methods that we can use is the case expression and the decode function. Starting with the case expression, you will write it in this format: case expression, which is the expression you're trying to evaluate. If that expression is equal to the comparison expression, then it returns the return expression 1. And you can cascade this as long as you want. Then you finish it up with the else function, which means if all these three, for instance, did not go through, then you return with the else function. We'll return with the else expression. Let's take a look at how that works. In this case, we're saying if the job ID is IT program, then the salary we multiply 1.10. We multiply the salary by 1.10. But if the job ID is store clerk, then we multiply by 1.15. If it's SA sales rep, then we multiply it by 1.20. Else, in other words, if the job ID is neither IT programmer, store clerk, or sales rep, then we'll return just the salary. Meanwhile, the decode function, on the other hand, it will achieve basically the same thing, only that it's written differently. And it's written as such: decode, you put your column or expression, then you put the first such condition. If that is true, then if the column or expression evaluates to this, then it will return result 1, and you can cascade this as long as you want, and put a default value, which will be the value that is going to result to if all your conditions are not met. Here's an example, similar example to what we just done before, where we're looking at the job ID, and we're saying if the job ID is IT programmer, we multiply by 1.10. If it's a store clerk, we multiply by 1.15. And if it's a sales rep, we multiply by 1.20. But if it's neither of these three, then we multiply by salary. And of course, we give it a revised salary as the alias. Here's another example where we're trying to use the decode function to implement an if then else. In this case, we're looking at the salary for the employees, and we're trying to implement the tax rate based on the table given in your manual, page 357. In this case, what we're doing is we divide because the increment is in 2000s, so we divide the salary by 2000. By the way, when you divide the salary, it will return the value straight into the trunc function. And by doing this, you can return it. With the trunc function will truncate the value into just one digit. I mean, just into one digit, and if it's 0, it indicates that value is particular salary is less than 2,000. Then you will use the tax rate of 0.00, and the same thing continues as per the table given in your manual. So in essence, we've talked about how to perform calculation on data using functions, how to modify data individually by functions, how to manipulate outputs of groups of row using functions, how to alter date format, and how to convert column data type into convert column data types to a different data type using functions. We've seen the NVL functions, and we've seen how to implement if then else logic. The practice 3 will help you understand all the subjects that we've talked about. This demo will show you how to use the dual table. Remember, we said that for a select statement to be complete, it must at least have the select and the from clause, which means you must be selecting from a table. And we said that if you're selecting from a table with just a select and the from clause, then you'll be returning a row for returning a record for each row in the table. Now consider the situation where we want to select our own literal expression. Let's say we want to select James from employees. This will return the character set James for every row in the record. The advantage that a dual table provides is that it is a single row table. So instead of selecting from employee, if we had selected from the table dual, then you would only have one row because it's a single row table. So that's the reason why the dual table becomes a very good tool when you're trying to write expression with some special functions. For instance, if you want to extract today's date, you would just say select sysdate from dual. Sysdate on itself is a function that returns the date, the present date. The same thing happens if you're trying to concatenate the sysdate with something else. That's the result. So the dual table provides us with a single row, single column scenario that will allow us to complete our select statement. This demo will show you how to use the substring function. In this exercise, what we're trying to do is to convert or is to display the phone number in the employee table, which is normally stored in this format, and display it in a different format, something like this. To start with, let's consider a basic select statement. You see the phone numbers here showing the way it's stored in the database. Now what we're trying to do again is to display this phone number in a slightly different format. To do this, I will go ahead and type in phone number, and I'll name that as new number format. Now we have two columns, so we can now play with this one to get what we want. Now to start with, the first thing we need to do is to put these three digits inside parentheses. To do this, all I have to do is to put the open parenthesis, concatenator operator, and get a substring of the phone number starting from position 0 and picking up 3 characters. In other words, I'm starting from here and I want to get the substring of this. I want to substring this by getting just these 3 characters. If I execute this, it should give us the open parenthesis 515. So we have effectively taken just the first 3 digits. Next thing to do to this, of course, is to add the close parenthesis, which we're going to do by using a concatenation operator and just putting the close parenthesis in single quotes. So now we have the first part of the new format that we're trying to go for. The next thing to do, of course, is to get these 3 digits in here, these 3 next digits, and put a space in between. To do this, first we have to count. You notice that this is 1, 2, 3, and the period is counted as the 4th position. Then the 5th position is number 1. So we have to do a substring starting from the 5th position and taking 3 characters. I will go ahead and put a space between this so there is a space showing up. Then I will go to the next level, not because, just for easy readability anyway. Then I want to add the substring. I need to spell that right. The substring of phone number again. This time starting from the 5th character, and I'll take 3 characters counting from that. If we execute that, it should give us 515123. You see that the space here is that space that I put behind this closed parenthesis. Now the last part of the deal is to get this last 3 digits, the last 4 digits. One of many ways, there are a lot of ways you can do it. One of the ways you can do it is to get the length of this and use it as a substring argument. In other words, we get the length, then subtract 4 from it. So we'll be getting the length, take 3 out of it because it starts counting from 0. Then we take the next 4 characters starting from there. So what we're going to do is we're going to add the substring, the phone number. Then we're saying go to the length, however long this phone number is, count 3 positions backwards, then take 4 characters and return it. Let's go ahead and execute that. It's pretty close to what we're looking for, only that we need a space in between. Then we can go ahead and add an extra space in here by doing concatenation operator, single quote with space between, and that should work for us. Let's go ahead and run that. That's perfect. That's exactly what we want. Now, there's this one way to do it. Quite a lot of different other ways to do it. The other way to do it will probably be, the simpler way to do it in this case will probably be to count. So if we count, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. We just return this. We replace this whole argument with 9. So we want it to start from the 9th position and take 4. If you execute that, so there are several ways of using the substring and the length, but it depends on what you're really looking for. You need to be able to look at your data and try to anticipate how all the data in the table is going to look like. Then based on that, you construct your substring expression.